Hi guys, this is Mrs. Gassler, and in this video we're going to talk about average atomic mass. So if you're filling out Cornell paper, you're going to need an essential question, and that essential question for this particular set of notes is, how do I find average atomic mass? Now, just to be clear, let's talk about what average atomic mass is, and I'm going to abbreviate because I don't want to write it out a whole bunch more. Average atomic mass. Now, you might also hear this as average mass or average atomic weight. The key word here is average. Whoops, all of these have average in them. Okay, so what we're going to be doing is finding an average. In fact, it's a weighted average. So there's something to take into account. Now, the definition of the average atomic mass is that it is the average, and it's a weighted average, of all the isotopes of an element. Okay. Now, in reality, each proton and each neutron, which contributes to the mass, doesn't add exactly 1. It adds a 1 plus a tiny little bit. But for all intents and purposes, we can what's the word? Boil it down to, simplify it by just looking at the average weight. So what we're going to do is we're going to look at an example here. And my example is lithium. Lithium is element 3. Lithium has 2 stable isotopes. We got to put that in there. It's only the stable ones. Sometimes they're radioactive and they don't last very long, and we don't count those because you don't find them in nature. But if you went outside, you could probably find some lithium mixed in with some other things. Some of it would be lithium-6, and some of it would be lithium-7. Sometimes it will have 3 protons and 4 neutrons. Whoops, this would be 3 and 3, and this would be 3 protons and 4 neutrons. So the difference there, again, with an isotope is that it has a different number of neutrons. But it's not half and half. Okay, if it were half and half, then the average would be what, 6.5? But there's quite a bit more lithium-7. In fact, 92.41% of all the lithium in the world is lithium-7. And only just a little bit, 7.59%, is lithium-6. That means that our average is going to be closer to 7 than it is to 6, okay? Because whatever there's more of is generally what the number's closest to. So this is what we do to find the average atomic mass of lithium, okay? So we're going to take the mass number, okay? And we're going to multiply it by the percent, but we have to put it in decimal form. Now, think back to math class. To get from this to the decimal form, we just have to move the decimal over 2 places, okay? Or divide by 100, whichever one you want to think about. You can do move to left or divide by 100, whichever you're more comfortable with. That's mathematically the same thing, so you can do either one. And then we're going to add up all the pieces. So I'm going to put a comma here, then add, okay? So for lithium-6, my mass number is 6. I'm going to multiply that by 0.0759. There's 2 decimal places there. So it was 7.5912 gave me the 0.0759. And then I'm going to do the same thing with lithium-7, but with its numbers, 7. And now to get my 2 decimal places, this will be 0.9241. And then I'm going to find those pieces, okay? So here's my trusty calculator. 6 times 0.0759, and I get 0.4554. That's kind of its contribution, okay? Maybe it's taxes, how much it has to pay. There's a lot more of this thing here, so it has to pay a little bit more. 9241, and I get 6.4687. And now I'm at the point where I'm going to add them. So I'm going to put a little bar here and a plus sign. And I'm just going to add those up in my calculator. You can do it by hand too. So I get 6.9241. Okay. Now the unit for this is grams per mole, or 6.9241 AMU. This is a little bit more useful later. Okay. This is AMU. Sometimes people just put the U on there. That is the unit for average atomic mass, and that stands for atomic mass unit. Okay, AMU is atomic mass units, and sometimes it's AMU and sometimes it's U. I think in the quizzes you can enter either one, but I'm not absolutely certain. So if one doesn't work, you can always try the other. Okay, so atomic mass units. So what if you had more than just 2 different isotopes? Okay, let's look at another example. What if I had cerium? Cerium is CE. I can't remember what number it is on the periodic table. I don't know if I could find it quickly enough. It's on the bottom somewhere, or in the middle. Either way, cerium has 4 isotopes. There's cerium-136, cerium-138, cerium-140, and cerium-142. Okay? Now, most of it is 140, 88.45%. The next biggest chunk is 142, 11.114%, and that's almost all of it. In fact, there's very little of these other 2, but they still exist. This one is 0.185, and this one is 0.251%. Okay, so we've got all our percentages there. Whoops, my hair is doing something funky. Sorry. All right. So I'm going to do exactly the same thing that I did with the lithium. I'm going to multiply the mass number times the percent, add up the pieces. I just have 4 instead. So I'll do 136. This one's a little tricky because I have to add zeros times 0.00185. And then I'll do 138 times again with the zeros there, 0.00251. A common mistake people like to make is to just put the decimal in front, which works on these 2, but it did not work on the 7 because I had to add the 0. Always make sure you add the 0. Then I've got 140 times 0.8845, and then 142 times 0.11114. Did I get the right number? 1, 2, 3, 4, 4. Yeah, okay. All right, so now I have to do some math here. Now you could do this all in one go if you're good at using a calculator and understand your order of operations. You don't have to do it one piece at a time and then add it up later, but I find it easier. I make less mistakes when I do it this way, just because I am not trying to go too fast and I don't forget something. So 140 times 0.8845, there's where most of it is, 123.83. Now real fast, what is this number, what our answer, what is it going to be closest to? So I've got 136, 138, 140, and 142. I have some gaps. The ones in between are not stable. They probably exist, but they aren't stable. Most of it is here. Is it going to be less than 140 or more than 140? Well, since there's more of this and quite a bit more of this than those 2 little ones, it's probably going to be in between 140 and 142. So 141 is in between 142. Is it going to be 141? Probably not, because there's more of this. So it's probably going to be between 140 and 141. Now the ratio of these 2 numbers would tell you if it's going to be closer to 140 or 141. But you know, that's kind of a difficult thing to think about. But as long as you have an idea of what the answer should be, then you can check your answer a little bit better. So 142 times 0.11114 is 15.78188. And I always keep all the numbers my calculator spits out until the end. And I'm going to add those up. 0.2516 plus 0.34638, 123.83. 15.78, whoops, 188. And I get 140.20986. Now, in order to round this one to 2 decimal places like you do in most questions, this 9, first off, to 2 decimal places means I'm going to keep the 2 and the next number. The 9 tells me I should round up, so this will be 140.21. Now, my unit I'm going to stick on there is an AMU. Later on, that turns out this to be the same as a gram per mole, and that's okay. We'll talk about that one later. All right, so there's a couple of examples on how to find average atomic mass. Make sure if you have any questions that you ask your teacher. Thanks for watching.